All right, so here we are with page 5. So we're told for number 12, g is a differentiable function, and g is always negative. Okay, mental note. F prime is equal to x squared minus 4 times g. Which of the following is true? And then we see we're being asked about f's relative extreme, maxes, mins, or none at all. Okay, so that means we need to do a first derivative test on f. Well, here's the first derivative of f. We need to figure out when that is equal to 0. Well, we know that g is always negative, so g will never be equal to 0. So really what we're looking for is when does x squared minus 4 equal 0? Well, if x squared minus 4 is equal to 0, that means that x squared is equal to 4 if we add 4 to both sides. And then when we take the square root, right, when we take a square root inside of an equation, we have to think positive or negative. So x is equal to 2 or negative 2. Hence the reason why we see those numbers right here. Okay, so there's our critical numbers. So we're going to place them on a number line. Pick some test values. Let's just go with negative 3, 0, and 3. All right. If we take negative 3 and we plug it back into the first derivative, we get 9 minus 4, which is positive. And then g we know is always negative. Positive times a negative is a negative. If we plug in 0, 0 squared minus 4, that's negative. G we know is negative. Negative times a negative is positive. And then when we plug in 3, we're going to get the same answer as before. 9 minus 4 is positive. G is negative. Positive times a negative is a negative. All right, so what are we being asked about? We're being asked about maxes and mins. So we have a function whose derivative is negative, and then positive, and then negative. So the graph is decreasing, and then increasing, and then decreasing. That's what's going to be the graph of f. All right, so we can see that we're going to have a min at negative 2, and a max at 2. Min at negative 2, max at 2. The answer is B. All right, 13 asks, when is the graph of y concave down? All right, so concave down means that f double prime is negative. So we need to get f double prime, or y double prime rather. So y prime, 12x cubed minus 48x squared plus 48x, and this 48 derives to 0. Y double prime is going to be 36x squared minus 96x plus 48. Well, those are some pretty big numbers. All right. Well, let's see. I can see right away, though, that all three of these numbers are divisible by 12, so we can factor a 12 out. And 12 goes into 96 8 times. All right, so we are deep in the heart of algebra land right now. 12 is never equal to 0, but 3x squared minus 8x plus 4 can be equal to 0. We're going to have to factor that into the product of two binomials. I see 3x squared right here, so I know that I have to have a 3x and an x. And now I just have to figure out the last part. Now with last, we're going to multiply to 4, which means we're either looking at a 4 and a 1 or a 2 and a 2. But in either case, both of the numbers will be negative because we have to add the sums up to negative 8. All right, well, if I go with 4 and 1, that's going to give me a 12. When I do 3 times 4, it can give me a 12. That's too far away. I think what we want here is 2 and 2. All right, and if we look at this, we put a negative and a negative. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Negative 2 times x is negative 2x. Negative 6x and negative 2x is negative 8x. Negative 2 times negative 2 is positive 4. So there's our factorization. And now when we look at this, cover them up one at a time. X is 2. X is 2/3. And if you don't see that, that's okay. Just do 3x minus 2 is equal to 0. Add 2 to both sides and then divide by 3. All right, so we've got 2/3. And we've got 2. Those are the critical numbers. And we see those numbers here for the most part. Actually, if anything's going to happen, it's going to be with these numbers. So right away, we can eliminate A and B. Okay, but when we do our second derivative test, we'll throw 2/3 on there, and we'll throw 2 on there. And we're going to pick some test values, but we're going to do so where we plug them into the second derivative. We're going to plug them in over here, or for that matter, here, or here. So let's plug in here. This is the factored version. If we plug in 0, 0 minus 2 is negative. 0 minus 2 is negative. Negative times a negative is positive. If we plug in 1, 3 minus 2 is positive. 1 minus 2 is negative. Positive times a negative is a negative. And if we plug in 3, 9 minus 2 is positive. 3 minus 2 is positive. Positive times a positive is a positive. We're interested when f double prime is negative. That's this interval right there between 2/3 and 2. So our answer is D.